I want to take a couple of minutes and show you how you can use Solid Edge with Synchronous technology on imported parts. I'm going to import a step file. This is of a jaw from a robotic competition. And you can see as I bring this in that it is just a single part. You can see that there's a part copy. It's just a single body feature. So there are no features, there's nothing to edit to make any modifications to this part. However, with Synchronous technology, we don't care how the model was created. We modify it however we want to. So I might come in here and I might add a dimension to the width of this jaw, and I want to make this an even 45 millimeters long. Key in the dimension and it modifies the geometry directly. If I want to change the height of this jaw, now notice that the light blue face is highlighted. If I start to make a change, you can see that that's the face that changes. If I flip the arrow to the bottom face highlights, and that's the face that changes with the modification. If I click the arrow in the center, the double-ended arrow, and I begin modifying that, you can see that it's going to stay centered on that jaw, which is what I want in this case. I'm going to make it 18 millimeters wide. So I'm making modifications to a part that I had no features to modify. If I come over here and look at this end, I can see that this has a set of teeth, like a gear, but there's no gear, there is no pattern to modify. Well, Solid Edge has some proprietary technology for recognizing patterns. All I need to do is select one gear tooth, and I'm just going to do that graphically by dragging a fence around those faces. Once I have those selected, I right click and Solid Edge goes out and says, yeah, I found a circular pattern of those teeth. In fact, 3 of the instances of that pattern have been suppressed. That's how powerful that is. If I go ahead and click OK, you can see what that does is it actually adds an editable pattern now in Synchronous technology, where I can click on that pattern and I can go from having 10 teeth to 12 teeth and modify that part as though it was designed in Solid Edge. Same thing over here. I'm going to run the recognize pattern again. I'm going to select one tooth, or one cutout in this case. I'm going to accept that, and it found that there is a linear pattern. Now that becomes an editable pattern in Solid Edge that I can come in here and I can maybe make it wider, make it fill that area on that jaw, and maybe change the count to 16. So there's no such thing anymore as a dumb solid. I modify this part however I want to change it. Right now I can see that there is, let me just turn off this PMI. So I can see that there is a ring here and there's a ring here that are symmetric about some center line. But I can see that my part is not centered on the base coordinate system, and I want to take advantage of Synchronous technology. So what I'm going to do is just hover here for just a second, bring up what we call quick pick. I'm going to pick my design body. I'm going to strategically place my steering wheel on the midpoint of one of these teeth. You can see it's not highlighting a midpoint, so I just need to turn that on. So it finds the midpoint of a tooth, it snaps into location. Now I decide I want to move that vertically and I want to center it on that base coordinate system. So now it's centered on the base coordinate system. I can take advantage of Synchronous technology and symmetry, so as I start to drag this, you can see that it maintains the symmetry and keeps it centered on that jaw. And I might move that out 2 millimeters. What about this angle? I could click on that face. I'm going to move my steering wheel down to this corner. Let's zoom out here so we can see what's happening. And if I click on that torus to begin to modify that angle, you can see again that it is also staying symmetric based on that base coordinate system. And I can keep it symmetric. So again, no such thing as a dumb solid anymore with Synchronous technology. You import the part, make the modifications however you want to change it. In fact, in most cases, I can modify the parts faster in Synchronous technology than the native software that part was created in, because it's a history-based model and would have to go back in history, make the modification, and hope that nothing breaks.